Hello, my people, to the last section of this semester. I hope you are as excited as I am. Here we go. Inverses of functions. So cool. Here we go. Find the inverse of. Okay, step one. Instead of f of x, let's write it as y, because that makes more sense. Step two, switch the x and the y. X equals 2y plus 8. Step three, solve for y. Get y by itself, for those of you that don't know what solve for y means. Subtract 8. So now we're left with x minus 8 equals 2y. Divide both sides by 2. So now you're left with x minus 8 over 2 equals y. Dunzos. That's it. Beautiful. Find the inverse of x squared minus 2. This is just basically restricting your domain. Okay, that's all that's doing, and I'll show you why here in just a second. So the first thing we do is rewrite it as y equals x squared minus 2. Then you switch the x and the y, so you're left with x equals y squared minus 2. Now we want to get y by itself, so we add 2 to both sides, just like that. And then to get y by itself, we have to square root. Okay, and so now we're left with y is equal to the square root of x plus 2 here. Okay, the reason why we're going to say x has to be greater than or equal to 0 is because we cannot take the square root of a negative number. Okay, so we're just going to restrict our domain just like that. Okay. Beautiful things. Moving on. Consider this function. Determine whether the inverse is a function or not. Okay, well, if we want to figure out if the inverse is a function or not, then we should probably find the inverse, right? So let's do this. We've got y equals 3x cubed minus 2. Switch the x and the y. Add 2 to both sides. Just like that. Okay, divide by 3. So now we've got x plus 3 over 3 equals y cubed. And then to undo the cube, you cube root. And then what I would do at this point is plug that into the calculator, the graphing calculator. Yes, I would. So I'd go here, I'd clear out these things, and I'd plug in, okay, well, the cube root of, and then I'm going to put the numerator in a parentheses, divided by 3, and close those parentheses there. That's what it should look like. And go to the graph. Okay. And then we've got that thing going on there. And remember the horizontal line test. Okay, if you can, or sorry, not the horizontal line test. I'm losing my mind. The vertical line test. If you can draw your pencil and it only crosses your function once the whole way over, then yes, this is a function. Woohoo. Good to go. Fantastic. Okay, awesome. Last one. No, not the last one. Second to last one. Lies. We want to determine whether the inverse of this function is a function itself. So we go y equals 3 times the square root of x plus 4. Switch the x and the y. Then we want to isolate the radical, so we divide both sides by 3. Then we square it. And because it's not really asking you what the inverse is, you can leave this really as ugly as you want it to. Okay, I mean, you could simplify that to be x squared over 9 if you wanted, but I don't really know why you would want to, because then to solve for y, then you just subtract 4. Okay, and then let's plug that into the graphing calculator. Let's see if that's a function. So we've got y equals, and then x over 3 squared minus 4. Go to the graph. Oh, would you look at that? That looks like a parabola, which we all know is a function. Woohoo! Yes. It's kind of a creepy smiley face. Anyway, last one. Last video of the year. Are you as excited as me? I don't know. I might cry tears of joy. Maybe sadness. I like you all. I don't know. Verify that f and g are inverse functions by showing composition, basically like that. Okay? So, here we go. We want to compose f and g so that g of x is basically inside of f. So, we know that f of x is equal to 2x plus 4. So f of g of x basically wants us to take wherever there's an x in our function f, we're going to plug in what g of x is equal to. Well, g of x is equal to this. So we've got 2 times, not x, but g of x, which is x minus 4 over 2, plus 4 from the plus 4 here. And then if we solve that, well, those two cancel. So now we're left with x minus 4 plus 4, which is equal to x. So we did it. We wanted to show that. Woohoo! All right, last one. If we want to find g of f of x, then everywhere where there's an x in our g of x, we're going to plug in f of x instead. So g of x is equal to this. So g of f of x is going to be 2x plus 4, in for this x here, minus 4 divided by 2. Plus 4 minus 4 goes away, so you're left with 2x over 2. Those go away, so that's x, and that simplifies. So that means that f of x and g of x are inverses. Woohoo! We have done it, and hey, guess what? Because you are such good students, because you have made it to the end of the last video of Chapter 5, which, man, I've spent an hour here making all these because I love you so dearly. I'm going to tell you there's one like this on your test. Bye. Don't tell your friends that, though. Shh.